Hello guys, my name is Bino, and in this video we'll be focusing on question 1 from the November 12, 2020 N6 mathematics question paper. Question 1.1, we are given the partial function z is equals to 1 over cos cube 5x plus 2y, and we are told to determine the partial derivative of z with respect to x. So we know that 1 over cos is equals to 1 over cos x is equals to sec x, but in this case, we have 1 over cos cube 5x plus 2y, so this will be equals to sec of 5x plus 2y cube, and we can write this as sec of 5x plus 2y all raised to the power 3. So we take that 3 and we put it there so that it can be easier for us to differentiate this. So let's differentiate the z with respect to x. So we first have to, number 1, we differentiate the brackets. Number 2, we differentiate the sec. And number 3, we differentiate what's inside the sec, the 5x plus 2y. So number 1, let's differentiate the parentheses. So we'll have 3 sec of 5x plus 2y. The 3 minus 1 will be equals to 2, multiplied by the derivative of the sec, which is sec tan. So it's going to be sec of 5x plus 2y tan of 5x plus 2y, and the derivative of what's, so number 3, the derivative of what's inside the sec. So the derivative of the 5x will be equals to 5, and because we are differentiating with respect to x, that y we treat it as a constant, so the 2y will be treated as a constant, and the derivative of a constant will be equals to 0. So from here we can simplify this. So this 3 multiplied by that 5 will be equals to 15 sec of, so that 2 we can write it there, 5x plus 2y multiplied by sec of 5x plus 2y multiplied by tan of 5x plus 2y. So the derivative of the sec tan is available on the formula sheet. So sec squared multiplied by sec will be equals to sec cube of 5x plus 2y. So that multiplied by that is equals to that. So now we are left with tan of 5x plus 2y, and this will be our answer for question 1.1. Equation x is equals to 1 plus 2t and y is equals to 3 over 1 plus 2t, and we have to determine dy over dx. So we have x is equals to 1 plus 2t, and y is equals to 3 over 1 plus 2t, which we can rewrite as 3 multiplied by 1 plus 2t. Since we are moving this 1 plus 2t from the denominator to the numerator, that exponent there is going to change from positive 1 to negative 1. So instead of deriving this using the quotient rule, we will just use the normal derivatives. So we have to differentiate the x with respect to t, and also differentiate the y with respect to t, and later we will divide, because the y is on top, we will divide the results of y with the results of dy over dt with the results of dx over dt. So the derivative of the x with respect to t, so the derivative of 1 is equals to 0 because it's a constant, and the derivative of the 2t will be equals to 2, and the dy over dt. So we first start by differentiating the parentheses, and later we'll differentiate what's inside the parentheses. So number 1, we the derivative of that, so we have negative 3 multiplied by 1 plus 2t. We minus 1 from that minus 1, and it will be negative 2 Number 2, we differentiate what's inside the parenthesis. So the derivative of the 1 is 0, the derivative of the 2t is equals to 2. Negative 3 multiplied by that 2 will be equals to negative 6. And we can take this 1 plus 2t raised to the power negative 2 to be our denominator. So it's going to change sign from negative 2 to positive 2. The exponent will change sign from that negative 2 to positive 2. So to determine dy over dx, so we have dy over dt. So we divide that because we have the division sign and the dx, so we divide that by dx over dt. So this division is going to change sign to multiplication, but we also have to, so this is dt, but we also have to take the denominator to be the numerator and the numerator to be the denominator, and that dt will cancel out with that dt and we'll be left with dy over dx. So we can just simply, to find the dy over dx without going through that, we can just take what's the dy over dt, the one which is on top, we have the dy. So the one which has dy here, we take it and we divide it with the one which is on top, so the dx over dt. So that division, we change sign from division sign to multiplication, and those will flip. So negative 6 divided by 2 will be equals to negative 3 over 1 plus 2t squared as our dy over dx. Question 1.2.2, we have to find the second derivative. So we already determined the first derivative as negative 3 over 1 plus 2t squared. So this was our first derivative and our second derivative. So we just have to differentiate that for the second time. But before we do that, let's rewrite it as negative 3 multiplied by 1 plus 2t raised to the power negative 2. So again, the denominator, the exponent is going to change sign when this goes from the denominator to the numerator. And we are doing this so that we can avoid using the quotient rule. But if you want to use the quotient rule, you still get the same answer. So d squared y over dx. So we differentiate this part to get this. We differentiate this first derivative to get this second derivative. And again, we first differentiate the parentheses and then we'll differentiate what's inside the parentheses. So the derivative of the parentheses will have negative 2 multiplied by negative c, which might multiply by negative 3, which will be equals to 6 into 1 plus 2t. Negative 2 minus 1 will be negative 3. And now we differentiate what's inside the parentheses. The derivative of 1 is 0. The derivative of 2t is equals to 2 is equals to 2 alone, not 2t. And 6 multiplied by 2 will be equals to 12. And again, we take this back to our denominator. And the exponent is going to change sign from negative 3 to positive 3. And this will be our answer for question 1.2.2. Please subscribe, like, and share this video with your fellow mates.